welcome back to my channel. I'm Preeti, a second year computer science and engineering student at Shri Venkateshwara College of Engineering, Bengaluru. In today's video, we will be discussing about logic gates and its applications. The table of contents of this video are introduction, types of gates, where we will be discussing about AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR and XNOR gate, and their applications and conclusions. Introduction. Here we will be discussing about the basic terminologies or the basic points related to logic gates. The word logic itself gives us an idea that they work on certain kind of logical operations. Logic gates are the integral part of digital mathematics. A logic gate is a device performing an elementary Boolean function producing a logical 0 or 1 output depending on one or several such logical inputs. Logic gates are the building blocks of digital circuits in which diodes and transistors are used to perform switching functions. By combining thousands or millions of logic gates, it is possible to perform highly complex operations. Our truth table helps us to show the function of a logic gate. It shows the output states for every possible combination of input states. Types of gates. And the first one is AND gate. An AND gate receives the input A and B, where A and B are bits and produce output denoted by A dot B. Here A dot B denotes the logical multiplication. And this is the logical symbol for AND gate. Truth table, we can see that when both the inputs are low or when any one of the input is low, the output is low. When both the inputs are high, the output is high. And the second one is OR gate. Similar to AND gate, it receives the inputs A and B, where A and B are bits and produce the output that is A plus B, which denotes logical addition. And is a logical symbol of OR gate. Truth table. When both the inputs are low, the output is low. When any one of the input is high or when both the inputs are high, the output is high. And the third one is NOT gate. NOT gate is quite different from other gates because it receives only a single input and produces a single output. A NOT gate, also known as inverter, receives input A, where A is a bit and produces output denoted by A dash. It is a complementary form of A. This is the logical symbol of NOT gate and truth table. When the input is 0, the output is 1, and when the input is 1, the output is 0. The next gate is NAND gate. NOT AND or NAND gate is equal to an AND gate followed by a NOT gate. The outputs of all NAND gates are high if any of the inputs are low, and the output is low when both the inputs are high. The symbol is an AND gate with a small circle on the output. The small circle represents the inversion. And the next gate is NOR gate. Not or NOR gate is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high, and the output is high when both the inputs are low. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. And the next gate is exclusive OR gate or XOR gate. The exclusive OR gate is a circuit which will give a high output if either but not both of its two inputs are high. An encircled plus sign is used to show the XOR operation. This is the logical symbol of XOR gate and the equation is A dash B plus AB dash. And the next gate is exclusive NOR gate or XNOR gate. The exclusive NOR gate circuit does the opposite to the XOR gate. It will give a low output if either but not both of its two inputs are high. The symbol is an XOR gate with small circle on the output. The small circle represents the inversion. So this is the logical symbol and the truth table of XNOR gate. And now we'll be discussing about the applications of logic gates. The applications of logic gates are mainly determined based upon the truth table, that is, their mode of operations. The basic logic gates are used in many circuits like a push button lock, light activated burglar alarm, safety thermostat, an automatic watering system, etc. Digital communication cannot happen without logical operations or logic operations. Daily life application of XOR and XNOR gate can be related to ladder switches used in homes or can be found in water level checker circuits. Now we'll be discussing the application of AND gate. AND gates are used to combine multiple signals. If all the signals are true, then the output will also be true. If any of the signals are false, then the output will be false. AND gates are not used as much as NAND gates. NAND gates use less components and have the advantage that they can be used as an inverter. NAND gate is used in security alarm. For example, we have the security alarm and the two inputs are light sensor and infrared sensor. The output is alarm, it is siren. Here, dark and intruder represents 1, and bright and no intruder represents 0. So, when the input is dark and intruder, we get the output as 1, that is, the alarm is on. Now, let's understand this with the help of a truth table. So, when the input is dark and intruder, the output is on, that is, alarm will be on. When the input is dark and no intruder, bright and no intruder, the alarm will be off. Now let's see the applications of OR gate. Whenever the occurrence of any one or more than one event is needed to be detected, or some actions are to be taken after their occurrence, in all those cases, OR gates can be used. For example, a doorbell system. So here the two inputs are front doorbell switch and back doorbell switch, and the output is doorbell. If either the front doorbell switch or back doorbell switch is pressed, then the doorbell rings. So this is similar to the truth table which we have seen earlier, which says that when any one of the input is high, the output is high. And now let's see the application of NOT gate. NOT gates are also known as inverter because they invert the output given to them and show the reverse result. Now the CMOS inverters are commonly used to build square wave oscillators which are used for generating clock signals. The advantage of using these is they consume low power and their interfacing is very easy compared to other logic gates. For example, a NOT gate based on heating concept. Here the input is temperature detector that is about 20 degrees Celsius and output is central heating. If the temperature is about 20 degrees Celsius, then the central heating is switched off. If the temperature is below 20 degrees Celsius, then the central heating is switched on. Applications of NAND gate. So the example is device failure alarm system. When all the fans are working, the input to the NAND gate is 111 because here we are considering three fans. So when the fans are working properly, the input to the NAND gate will be 111 and output is 0. If any one of the fans stops working, the output to the NAND gate becomes 1, which activates the alarm. The two more applications of NAND gate are burglar alarm and freezer warning buzzer. Burglar alarm. When the switch is closed, one input of the NAND gate is low. When the LDR is in the light, the other input is low. This means that if either of these things happen, that is, the switch is closed or the light is on, one of the inputs is low and the output is high and the buzzer sounds. Freezer warning buzzer. When the thermistor is cold, its resistance is large and the input to the NAND gate is high. Since the NAND gate is connected as an inverter, the output is low. As the thermistor warms up, its resistance decreases, the voltage across it falls, and the input to the NAND gate falls. When it becomes low enough, the output becomes high and the buzzer sounds. Applications of NOR gate. An example is washing machine controller. A washing machine has three sensors to check for washing machine lid open, washing tub filled to minimum level, and weight of clothes and water in the tub. If the machine lid is open or the water in the tub is below certain level, or the machine is overloaded, that is weight of water and the clothes in the tub is above certain limit, the output of the corresponding sensor is set to 1, producing a 0 at the NOR gate output that switches the machine off. Now we are at the end of the session, so let's have a conclusion about today's topic. In conclusion, logic gates form the building blocks of modern digital systems, enabling the design of circuits that perform complex decision making tasks. Their application extends beyond simple computational functions to real world systems like security alarms and household appliances. This exploration demonstrates the versatility of logic gates and their foundational role in advancing technology through Boolean mathematics, making them essential in both theoretical and practical engineering solutions. Thank you for watching. Please do like and share the video.